Hi, my name is Kingsley Linus. In today's mathematics lesson, we'll be learning about simple equations. By the end of this lesson, you should be able to know what an equation is, and secondly, you should be able to translate word sentence into mathematical equations. Let's talk about algebra. Algebra is a branch of mathematics that deals with equations. I will tell you what an equation is, but before then, algebraic expressions usually contain symbols and alphabets. These alphabets are usually called unknown or variables. Now, to what an equation is. An equation is simply a mathematical statement that says two things are equal. Usually, an equation has a left side and a right side, and these two sides are connected by an equal to sign. The word equation is derived from equal. Of course, we have our equality sign here. Solving an equation simply means figuring what the unknown is. It is important to know what a simple equation is. The best picture to describe a simple equation is a balance scale. You can see a balance scale here. Equations usually have unknown values. These unknown values, like I mentioned earlier, can also be called variables. Now, when we solve for these unknown values, we have succeeded in solving an equation. Here we have an example. We have unknowns like 4u, 5x, and 3x. These terms contain variables. In order to solve this equation, we basically rearrange this equation to get it to be balanced. By that, we have succeeded in solving the equation and finding out the unknowns. Let's look at the steps involved in solving a simple equation. To solve a simple equation, our goal is simply to find out what the unknown is. That is the value of the unknown. To do this, we must isolate the variable. Now, what do we mean by isolating the variable? To isolate the variable, we add or subtract the unknown values on the variable side. And then we also do the same thing on the other side. We keep doing this until only the variable is left on the left-hand side. Now, when we have the variable on the left-hand side, we can then assume that the other part, or whatever we have on the right side, is the value of the unknown. Similarly, when we have the variable on the right side and every other information on the left side, the solution can be what we then have on the left side. Now, let's look at some examples. The first example, we have x plus 7 equal to 15. And the second example, we have 17 minus 9 equal to 5. Now, to solve that, for the first example, where we have x plus 7 equal to 15, recall that I mentioned the first thing to do is to isolate the unknown. So we must start arranging our equation to have the unknown on one side, the left-hand side. Now, to do that for this equation, we have to subtract 7 from both sides of the equation. It is one rule whenever we are solving an equation that whatever we do on the left, we must do the same on the right. Now, we have x plus 7 minus 7 and 15 minus 7. So when we solve that, we'll have x alone on the left-hand side, then 15 minus 7 on the right-hand side. Now, 15 minus 7 gives us 8. So x is equal to 8. So the value of our unknown x in this equation is 8. To the next example, 17 minus q equal to 5. Again, we isolate our unknown. Our unknown is q. So to isolate q, we add q to both sides. When we add q to the left-hand side, we would have this 17 minus q plus q. And when we add q to the right-hand side, we would have 5 plus q. Now, 17 minus q plus q, of course, this would cancel this out. So we have 17 alone left on the left-hand side. And then we have 5 plus q on the right-hand side. Again, we still have to isolate the unknown because we need the unknown to be left alone. So we subtract 5 from both sides of the equation. 17 minus 5, and on the right side we have 5 minus 5 plus q. So 5 minus 5 gives us 0. So we have q successfully alone on the right-hand side. 17 minus 5 gives us 12. So the solution to this problem is that our unknown q is equal to 12. Let's move on in this lesson to find out how we can translate words to mathematical equations. Mathematics problems sometimes use words to describe events. We refer to such situations as word problems. In order to solve these word problem questions, we must be able to interpret the questions mathematically. So to do that, we can easily solve the problem using mathematical methods. And that is what we are about to find out. Now, there are steps that have been listed on how we can go about translating word problems into mathematical statements. First, we must read the question carefully. Secondly, we must observe the important aspects of the question. Thirdly, we must represent important parts with the appropriate mathematical symbols. And lastly, we can write out the mathematical equation for the problem. Let's see some examples that explain the steps that I just listed. Translate the following sentences into mathematical statements. A. Akin writes down a number. His teacher asks him to add 5 to it. The sum of the two numbers is 14. To solve that, let's assume the number Akin writes down as x. So we say let x be the number. The next information says he adds 5 to the number. So 5 plus x. Okay? Now, the last part of the question says the sum of the two numbers is 14. That means when we add 5 plus x is equal to 14. So, this mathematical statement clearly expresses what this word problem says. To the next example, it says, Belema is a pupil. Soba is her cousin, whose age is twice the class in which Belema is currently in. If 3 is subtracted from Soba's age, the result is 7. So just like we did in the first example, let P be Belema's class. P is our unknown. P is what we are interested in finding out. But our aim here is not to solve for P, but we want to express, or we want to form a mathematical statement that expresses this story in this question. Soba's age from the question is 2 times Belema's class, and we have said that Belema's class is represented with the letter P. So Soba's age would be 2 multiplied by P, and that is 2P. Now, the next part of the statement says subtract 3 from Soba's age. So we have 2P minus 3. And then lastly, the last part of the question says that if we subtract 3 from Soba's age, the result will be 7. So we have 2p minus 3 equal to 7. This mathematical expression clearly represents the story in our second example. Let's see some more examples. Translate the following sentences into mathematical statements. When 3 is subtracted from a number, the result equals twice the number plus 5. To solve this example, we have to give a name to the unknown. So we say, let y be the number. Now, the instruction says subtract 3 from a number. So we can take 3 from y. So y minus 3. Now, the second part of the statement says that the result equals twice the number plus 5. The number here refers to the unknown. So y minus 3 equals 2 times y plus 5. So the statement, the mathematical statement that expresses the story we have above is y minus 3 equal to 2y plus 5. To the next example, when 2 is subtracted from 6 times a number, the result is the same as when 2 is added to 5 times the number. Now, we call the unknown q. In this case, it says subtract 2 from 6 times the number. So, 6q minus 2. Then, the statement went ahead to say that the result we would have is the same as when 2 is added to 5 times the number. 2 added to 5 times the number is written as 2 plus 5q. Now, we have it that 6q minus 2 is equal to 2 plus 5q. So, this statement expresses the story we have in our question. Having seen these examples, it's time to do it yourself. Pause the video and try out the questions. I'm sure you are done. If you have solved correctly, exercise 1 says find the value of s. S plus 3 equal to 19. The value of s is 16. For question 2, it says translate this statement to an equation. BC had C books. She was given 5 more. The answer here is C plus 5. Question 3 says translate to an equation. 5 multiplied by a certain number is added to 2. The result equals 4 times the number plus 4. The answer here is 5n plus 2 equal to 4n plus 4. Of course, in your answer, the letter n here can be any other letter of the alphabet. If these were your answers, you are correct. This is where we come to the end of this lesson. But before you go, let's look at a summary of all we've learned. First, we learned that an equation is a mathematical expression that says 2 things are equal. Secondly, we learned that a simple equation consists of an expression with unknown values, also known as variables, on the left-hand side, connected to the quantity on the right-hand side with an equality sign. Moving on, we learned that equations can have unknown values on one side alone, or the 2 opposite sides, e.g., 4u equal to 64, 5x plus 4 equal to 3x plus 7. Next, we learned that solving an equation means figuring out what the unknown values are. And lastly, we learned that word problems involving simple equations can be translated into mathematical expressions and solved. Before you go, I have some test questions for you. Question 1. The equation 9 equal to 14 minus x is true when dash. A, x equal to 2. B, x equal to 3. C, x equal to 4. Or D, x equal to 5. The correct answer is option D, x equal to 5. Question 2 says, adding 7 to a number is the same as subtracting 4 from double the number. What expression interprets this? Option A, 7 plus 4 equal to 2x. Option B, x plus 7 equal to 2x minus 4. Option C, 2x minus 7 equal to 4 plus x. Or option D, 7 plus x equal to 4 minus 2x. The correct answer is option B. We will be learning more of these in the part 2 of this lesson. But till then, bye-bye.